A machine in eastern China swallows 100 kilograms of used clothing and spits out an answer in under 3 minutes. A city of 20 million people is about to burn a third of its own garbage inside a single circular building covered in solar panels. And a town once called the most toxic place on Earth is now pulling gold out of your old smartphone on a conveyor belt. None of this is science fiction. It is happening right now in 3 different corners of China. And together, it adds up to one of the strangest industrial transformations happening anywhere on the planet. Stay with this, because the machine sorting your old t-shirts is only the smallest part of the story. This is not a fringe experiment or a government press release with nothing behind it. The clothes sorting machine was built by Data Beyond, an AI recycling company founded in 2018, and it was named one of Time magazine's best inventions of 2025. It is currently running inside a real facility, Shanhaisheng Environmental Technology, in the city of Zhangjiagang on China's east coast, and it was documented on site by the Associated Press in March of 2026. The waste-to-energy plant is being built by Shenzhen Energy Group, designed by the international architecture firms Schmidt, Hammerlassen, and Gottlieb Paludan, using combustion technology from Babcock and Wilcox. And the e-waste town, Guyu, has been studied for over a decade by public health researchers, environmental groups, and Chinese state media alike. 3 real places, 3 real technologies, and 1 country trying to solve a garbage problem so large that most of the world has simply looked away from it. Here's a way to picture the scale of what China is dealing with. Imagine every single piece of trash generated by a mid-sized American city in a year, and now imagine that same amount of waste showing up again in about 6 weeks. That is roughly the pace at which one Chinese metropolis alone produces garbage. Shenzhen generates around 15,000 tons of waste every single day. Stack that in shipping containers, and you would need a line of them stretching for kilometers, so refreshed daily, forever, unless something changes. That single comparison is the reason this entire story exists. Let's start small, with the machine that started this whole video, the fabric scanner in Zhangjiagang. Picture an airport baggage scanner, except instead of reading what's inside a suitcase, it reads what a piece of clothing is actually made of. Workers load stacks of used garments onto a conveyor belt, and the belt carries them through a scanning unit measuring about 5 meters by 2 meters. As each item passes through, the machine emits a short, sharp hiss and reads its exact fiber composition, cotton, nylon, polyester, in less than 1 second per item. A live video feed on the side of the machine shows the reading in real time. Then a robotic sorting arm routes each item into the correct bin based on what it actually is, not what a tired human eye guesses it might be. Before this machine existed, sorting clothing by fabric type was almost entirely a manual job. A single trained worker could sort through a pile of textiles in roughly 4 hours to process the same volume this machine handles in 2 to 3 minutes. 2 workers, according to Shanhaisheng's own internal analysis, would need 2 full days to match what the machine processes in a single hour. And even then, human sorters routinely misjudge whether a garment is 80% or 90% polyester. The AI system, according to the company, rarely makes that mistake. This matters enormously because textiles are not one material. They're often a blend, and blended fabrics are notoriously difficult to recycle unless you know exactly what's in them. That precision is already changing outcomes on the factory floor. Before the fast sort textile machine arrived, up to half of everything Shanhaisheng processed was judged unrecyclable and sent straight to landfill or incineration. With the AI scanner sorting by exact composition, that number has dropped to around 30%, according to the facility's sales director. That is not a marginal improvement. That is roughly a fifth of an entire waste stream being pulled back from destruction and pushed into a second life, purely because a machine can now tell fabric types apart with a precision no human sorting line ever consistently achieved. Here's the part that gives this story its urgency. Synthetic textiles, the kind made from petroleum-based fibers like polyester and nylon, now make up around 70% of all textile production worldwide, according to the Amsterdam-based nonprofit Circle Economy. And China isn't a bystander in this. China led the entire world in textile exports in 2025, shipping out $142 billion worth of clothing and fabric, more than double the entire European Union combined, according to World Trade Organization data. A country that dominates global textile manufacturing is also, unavoidably, the country left holding the largest share of textile waste. That's the uncomfortable math behind why a sorting machine in a small industrial park has ended up on a list of the world's best inventions. And there's a longer-term ambition baked into this technology that sounds almost eerie. According to Shanhaisheng's sales director, the end goal isn't just faster sorting, that runs entirely without people, what the industry sometimes calls a dark factory, machines running the sorting line 24 hours a day because, in his words, human energy is limited and machines don't get tired. Whatever you think about that vision, it tells you something about where this technology is heading next. If a story like this makes you rethink how much of your own closet might be fossil fuel in disguise, that's worth a like before we keep going, because the next part of this gets a lot bigger than clothes. Now, here's the part that connects a single sorting machine to something almost unbelievably larger. Sorting is only step one. Once you've separated what can be recycled from what can't, you still have to deal with the leftovers, and China's answer to that problem is being built right now on the mountainous outskirts of Shenzhen. It's called the Shenzhen East Waste-to-Energy Plant, and once fully operational, it is designed to be the largest facility of its kind anywhere on Earth. Now here's the part that connects a single sorting machine to something almost unbelievably larger. Sorting is only step one. Once you've separated what can be recycled from what can't, you still have to deal with the leftovers, and China's answer to that problem is being built right now on the mountainous outskirts of Shenzhen. It's called the Shenzhen East Waste-to-Energy Plant, and once fully operational, it is designed to be the largest facility of its kind anywhere on Earth. Picture a single circular building, its roof nearly the size of 10 football fields laid side by side. 66,000 square meters in total, with up to 44,000 square meters of that roof covered entirely in solar panels. Inside, the plant is designed to incinerate up to 5,000, in some estimates closer to 5,600 tons of municipal solid waste every single day. That's roughly a third of everything Shenzhen's 20 million residents throw away in an entire year, burned continuously, converted into electricity through 6 massive combustion grates and a central turbine system. The plant is projected to generate around 550 million kilowatt hours of electricity annually, enough to meaningfully offset the very fuel it took to build it. The design itself is unusual for an industrial facility of this size. Rather than the typical rectangular layout of a power plant, the entire structure, including offices, exhibition halls, and visitor facilities, is organized into one continuous circular building. Visitors enter through a landscaped public park, cross a bridge that rises between the plant's smokestacks, and can walk a 1.5-kilometer elevated public walkway across the rooftop, looking out over both the machinery below and the surrounding mountains. It was designed this way on purpose, as a piece of public education as much as an industrial facility, an attempt to make the invisible process of burning a city's garbage something residents could actually walk through and see for themselves. And this plant is not an isolated example. China now operates more than 300 waste-to-energy facilities nationwide, with installed capacity that has grown by roughly 26% a year over the past 5 years, compared to an average of just 4% annual growth across wealthier OECD nations. Shenzhen's plant is the flagship, but it sits inside a much larger national build-out. In the next part of this, we go straight into why China needed a plant on this scale in the first place. For decades, a huge share of the world's recyclable waste, plastics, paper, scrap metal, from wealthy countries was shipped directly to China for processing. Cargo ships left Los Angeles, Rotterdam, and Sydney loaded with bales of mixed recycling, and much of it landed in Chinese ports to be sorted, cleaned, and fed back into manufacturing. Then, in 2018, China introduced what's known as the National Sword Policy, banning the import of contaminated foreign scrap and demanding purity levels below 0.5% contamination, a threshold manual sorting simply could not reliably hit. Overnight, recycling systems across North America, Europe, and Australia were thrown into crisis because the country that had quietly been processing much of the planet's waste had just said no more junk. Warehouses in the United States and the United Kingdom began stockpiling recyclables with nowhere to send them. Some cities simply started sending recycling straight to landfill because there was no longer a buyer for it. What almost nobody outside the industry realized is that this policy didn't just close a door to the outside world. It forced China to turn that same intensity inward onto its own domestic waste stream. And that pressure is a direct line to why facilities like the Zhangjiagang sorting machine and the Shenzhen plant exist today. China still generates more municipal solid waste than any other country on Earth, according to World Bank figures, and closing the door on imported scrap didn't make that domestic mountain of garbage disappear. It simply meant China now had to build the sorting and processing capacity it used to rent out to the rest of the world, and build it fast enough to keep pace with a population of 1.4 billion people still generating more waste every single year. Quick recap before we go further, because there's a lot stacking up here. You've got an AI machine in Zhangjiagang that can read a garment's fiber composition in under a second, a policy shift in 2018 that forced China to stop exporting its waste problem and start solving it domestically, and now a 5,000-ton-a-day incinerator rising outside Shenzhen that turns what's left after sorting into electricity for the grid. 3 pieces, 1 system. But there's a fourth piece to this story, and it might be the strangest turnaround of all. Go back about 15 years, and there was one place on Earth that environmental researchers routinely described as the most toxic town in the world. It's called Guiyu, a cluster of villages in Guangdong province, and for years it existed almost entirely on one grim industry, taking apart the world's discarded computers, phones, and circuit boards by hand, often over open flames, to extract small amounts of gold, copper, and other valuable metals. Health researchers publishing peer-reviewed studies documented severe lead exposure in local children, alongside contamination of soil and water so extensive that Guiyu earned nicknames like Junk Town in international reporting. Then, starting in 2015, local authorities did something dramatic. They shut down thousands of small, unregulated backyard operations, more than 5,000 of them, and consolidated the entire industry under one roof, the Guiyu Circular Economy Industrial Park. Instead of workers cracking open circuit boards with hammers and burning wires in the open air, the new facility runs conveyor belts fitted with AI-powered scanners that identify reusable components automatically, followed by closed-loop extraction systems that pull gold, copper, and rare earth metals out of discarded electronics without the open burning that made the old Guiyu so dangerous. According to municipal reports, this shift has cut environmental contamination from the industry by roughly 95%. Think about what that actually means in practice. A smartphone that arrives at Guiyu today no longer gets torched over an open flame to melt away the plastic casing and expose the copper underneath, a process that used to release a toxic haze of dioxins and heavy metal particles directly into the air people were breathing. Instead, that same phone moves down a conveyor line where a camera-based scanner identifies its model and internal layout. Robotic tools separate the battery, the circuit board, and the casing into different streams, and each stream goes to a dedicated chemical or mechanical process built specifically to recover what's inside it without burning anything in the open. It's the same underlying idea as the fabric scanner in Zhangjiagang. Replace a crude, imprecise, often dangerous manual process with a machine that can tell materials apart accurately at speed without a human standing over an open flame all day. Here's the number that puts this in perspective. Guiyu's industrial park now processes about 15% of all the electronic waste generated across the entire country. Over 1 million metric tons of old phones, laptops, and circuit boards every single year. 1 million metric tons. That is not a neighborhood workshop anymore. That is an industrial-scale mining operation, except instead of digging into a mountain, it's digging into a landfill's worth of yesterday's electronics, and it now employs around 30,000 workers in what officials describe as safety-certified roles, feeding an industry, now valued at close to $7 billion. What used to be humanity's electronic waste dump has become, at least on paper, a case study in urban mining done right. Now here's what makes all three of these stories connect into something bigger than any one of them alone. A country that dominates global manufacturing inevitably ends up holding a disproportionate share of the world's waste when those products reach the end of their life. China makes an enormous percentage of the world's clothing, an enormous percentage of the world's electronics, and consumes and discards an enormous volume of everything in between. For years, the solution was exporting the problem or burying it. What's happening now in Zhangjiagang, in Shenzhen, and in Guiyu is an attempt to turn that liability into a resource stream instead, using artificial intelligence to sort what humans physically cannot sort fast. Enough, or accurately enough at this scale. There's also a question worth sitting with here. Is this actually working as well as the numbers suggest? Or is some of this simply better public relations wrapped around a genuinely hard problem? That's worth being honest about before this video wraps up. Because, to be clear, none of this is without real controversy, and it would be dishonest to end this story without saying so. The Shenzhen East waste-to-energy plant has faced consistent opposition from local residents and environmental groups who worry about dioxin and other toxic emissions from continuous large-scale incineration, regardless of how advanced the combustion technology is. Architects and engineers involved in the project argue that modern waste-to-energy incineration releases roughly half the carbon emissions of an equivalent landfill, but half of a harmful baseline is still not the same as clean, and that distinction matters. Nobody involved in this project is claiming incineration is a perfect solution, only a less damaging one than the alternative of endless landfill expansion around a city of 20 million people. The Guiyu turnaround deserves the same honest scrutiny. The 95% contamination reduction figure comes from municipal reports, not independent third. Party environmental audits and self-reported statistics from local government sources should always be treated with some caution, rather than taken as final proof. Decades of lead in heavy metal contamination don't simply vanish once a new facility opens next door. soil and groundwater contamination in the region built up over years, and peer-reviewed health studies on Guyu's children were documenting lead exposure as recently as 2021. The industrial park represents genuine, measurable progress in how the work is done today, but it does not erase the environmental and public health legacy already embedded in that ground. And it's worth being precise here. Population level, improvements in a facility's emissions do not automatically mean every individual worker or resident nearby has been made fully safe. Those are two different claims, and only one of them has strong evidence behind it right now. Even the AI sorting machine in Zhangjiagang, the least controversial piece of this story, is still a single installation. As of the reporting available, the fast sort textile system is operating in exactly one location in the entire country. It's a proof of concept that's working, and working impressively, but it is not yet the standard for how China's roughly 1.4 billion people sort their textile waste. Whether this scales into thousands of facilities or remains a showcase project featured in international magazines is genuinely still an open question. And even Data Beyond's own leadership frames the ultimate goal, a fully automated dark factory with no human workers at all, as a future ambition rather than something already achieved. What exists today is one very impressive machine in one industrial park, not yet a nationwide system. It's also worth being honest about a broader pattern here. Waste to energy incineration, urban mining of e-waste, and AI-assisted sorting are not unique to China. Countries across Europe, the United Arab Emirates, and parts of the United States are experimenting with very similar tools. Robotic arms from companies like Zen Robotics sorting waste in Dubai, near-infrared scanners identifying plastics in facilities across the West. What makes China's version of this story distinct isn't that the technology itself is unprecedented. It's the sheer scale at which it's being deployed, driven by a population, and a manufacturing base large enough that even a single incinerator has to be sized to swallow 5,000 tons a day just to make a dent. So where does that leave things? A machine that reads fabric composition in under a second, a 5,000-ton incinerator turning garbage into electricity for a megacity, and a town that clawed its way back from being called the most toxic place on Earth into a certified industrial recycling zone. All three are real. All three are documented. And all three come with real, unresolved trade-offs that no amount of AI can fully sort away. That tension between genuine technological progress and the messy, sometimes toxic reality underneath it might be the truest picture of what China's waste crisis actually looks like right now. Think back to that machine we opened with, quietly hissing as it reads a pile of old clothes, one garment at a time. It's a small, almost boring-looking piece of industrial equipment. But trace the thread far enough, from that scanner, to a policy decision in 2018, to a circular building rising outside Shenzhen, to a town that used to burn circuit boards in the open air, and you start to see the outline of a country trying to engineer its way out of a waste crisis of its own making, one conveyor belt at a time. Whether it fully succeeds is still being written. Tell me in the comments which surprised you more. A machine that can sort 100 kilograms of clothing in under 3 minutes, or a town that went from the most toxic place on Earth to processing 15% of a nation's e-waste.